Okay, February 22nd, going through, we are going over the ionic covalent compounds maze. Sorry, just realized I hadn't started recording. So going through carbon tetrahydride, we've made it this far, figured out carbon. All the ones that are not lined out yet have carbon. Tetra we figured out was 4, so now we're going through and lining out anything that's not 4. Hydride is hydrogen. So on this one, we've only got 1 hydrogen. This one's 5 hydrogen, tetra's 4. This one, 3 hydrogens, tetra's 4. And on this one, those are all done. Can't do that one. Oh, here we go. 4 hydrogens. So now we'll run in this direction. Formula for iodine trichloride. Okay, so now we're looking for tri is which one? What number for tri? 3. Okay, so we're looking for 3 chlorines. So now we're going to pull out anything that's not an I. Well, take care of that, take care of that. So we've got these 2 are the only ones left. So I want 3 chlorines. There's 3 chlorines. Double check my other one, 4 chlorines. Nope. Okay, now we go dinitrogen tetroxide. Dinitrogen, how would I recognize that? Dinitrogen would be, anybody at the home audience? Dinitrogen? Anybody in the classroom audience? 2, yes, we have 2 from the back row, all right. So dinitrogen is 2 N's. So we can go through and do that. Hey, all right. 2 N's, great. 2 N's, not so great. 2 N's, definitely not great. So all 3 of those have 2 N's. So now we got to go to the next piece. Tetroxide. Tetroxide. So it's oxygen. They all have oxygens. Tetra would be what number then? 4. All right. So that's 5. Rule that out. That's 7. So we're going N2O4. Gone that route. Excellent. Nitrogen monoxide. So N, great. Mono is 1. There's 3. Nope. 2. Nope. 1. Hey, there we go. Sulfur hexafluoride. So hexa is what number? Just show of fingers if you're not going to say anything. 6. Yes. Well, there's 7. There's 6. Now, would it really matter? Well, it could because we can be going up, but none of those are sulfurs, so we're not worried about that. So on your Google form, I didn't make you actually line out which ones. I just had you put my number set. So on this one, what you would have put for the number set, 1, 6, 5, 8, 9, 10, 7. And that's what you would have been putting down here at the bottom piece. And that's the one you would have chosen for the thing on the maze. Make sense? Just kind of a review of what we've been doing. Okay, on the ionics, you had to go formulas and names. On this one, can you guys, real quick, all I'm going to have you do is tell me left, right, or down from each spot. Okay? That's all I'm going to ask you guys to do. So, from this first one, from start, what's the chemical formula for iron 3 chloride? Am I going right or down? And I'm counting on you to tell me the right thing. Is it right or down? Hey, you need assistance? Yes? Okay, so hey, let's go for assistance. What does that piece tell me? What number is that? 3. What's 3? What does that Roman numeral tell me is 3? This is the piece you need to remember. This is critical. You're going to start seeing this a lot in the equations we're doing, in the formulas, in the labs. You need to remember that aspect. That's one reason we're spending some time doing this. And I don't know why it keeps doing that.
It's iron.
Iron what? Okay, that's the piece we need. You're right. It is connected to the iron. There's 2 things it can be. It's iron's charge, exactly. That means the charge on that iron is a +3. And that's the key piece, is that the Roman numeral is always the charge. The Roman numeral is always the charge. And then we've got chloride, which is Cl. Get your periodic tables out if you, I forgot to ask you already to do that. Pull your periodic tables out. Yes? Okay, fine. Get it memorized. That's good. Okay. So, -1, excellent. In which case, you probably already figured out where to go next, right? Okay. How many of them you got memorized?
Just like a few, like, I don't know.
You probably didn't even realize you were memorizing them, did you? That's the sad part. Is you start realizing, like, oh, I know that formula. I know that. It's like, why do I know that? It's called learning. I'm sorry. Lady, you got a periodic table?
No, I actually left my case at home. I have my timer.
Your case?
Yeah, my sister was sleeping in my room bar, so I couldn't work.
Oh, just wait the cup.
No.
Flip on the legs and then
He
also
works
put
so
it on it.
hard. He needs a break. He needs to sleep.
I need to sleep. Tell that to my dogs. One wants to get up at 2:30 in the morning to go out to the bathroom. The other one wants to get up at 4:30. I don't get up till 5:30. Or so I thought. They don't care. Okay, so it's a -1. +3 minus 1. That doesn't add up to 0, and it has to. So what was the trick we said to do? What was the trick we said to do on this? Yeah, cross them down, right? So this 3 comes over here, and that 1 would come down there, right? Remember, just because we wrote it kind of implies we have 1 of them. Okay, so you can write it there. I choose not to, just because to me it's saving graphite. So 1 times 3 is 3. 3 times -1, 3. 3 minus 3 is 0, right? That's what it has to do. So FeCl3, Fe3Cl, nope. FeCl3, got it. Fe2Cl3, no idea why. FeCl, forgot that. So in this case, we are just going right. Name of the compound, Na2CO3. Now, because of the fact there are 3 capitals, what is present? I have 3 capitals there. So what does that mean I have 3? 3 of what? Three what? I have 3 elements, right? Now, if I have 3 elements, what type of compound was it? It's a polyatomic. So with that, that means we've got what's called a polyatomic ion. Where would I find the polyatomic ion? Where would I find the polyatomic ions? At the bottom of your periodic table, right? So if you look at your periodic table, if you look on the bottom, you're going to find your polyatomic ions. So you need to find, and if you notice on these, notice that there's only one that's in boldface, and that has a positive charge. All the rest are negatively charged. Where do you find the ones that have negative charges in a compound? Where do we find the things that are negatively charged? Where do we always find the negatively charged things? Well, where do we find it here? If I was going to form a compound between this element and this element, which one of those would I write first? Between this one and this one, which of these would I write first? I'd write sodium, right? Sodium and then I write chlorine, correct? What if I was doing Fe and N? Which one of these would I write first? Iron. So I'd go Fe and then N, right? What if I'm doing C and then Cu? Which one of these would I write first? Between C and Cu, which would I write first? The Cu, right? All of these have what charge to them? Positive. So which things are we always going to be writing first? What did we write first in all those examples? Which one did you write first? The metals or what charges? The positives. We always write the positively charged things first. So because all these are negative, we always write them in the second part. That's the only one that will ever be written first because it's the only positive we use. Now here's the reason I was getting at that. In here, Na2CO3. Which of these set is going to be my polyatomic? Well, with that, we said this back half is going to be the negatively charged piece, right? So I've got 3, so I can immediately block off 2 of them, right? So can you find CO3 on that list? What is it? What's CO3? Carbonate. Do we agree on that one? And what's its charge? It's -2. I'm just going to put it over here because I got no room there. And that means we have Na left. And what's the charge of Na? +1. So we have 2 Nas. What's 2 times 1? What's 2? And there's 1 CO3, so 2 minus 2 is 0, right? So we actually pulled that out. So now we can go through and check our names. But I wanted you to see how we got that. Sodium carbonate. Well, that makes sense, right? That's kind of what we figured out. Let's pull out the rest of it. Sodium carbon. Well, we figured out that's not right. Sodium carbide. Hey, if it's IDE, how many elements are there? Just 2, right? We got 3 capitals. We stressed that. Can't be that one. Trioxide. That's indicating how many elements? Just 2, right? The one exception, actually, there's 2 exceptions that you have to memorize these. The 2 exceptions are hydroxide and cyanide. Okay. I can show you a trick on one of these, and it's up to you to actually always connect it. If you just see hydro, what element do you think of when you see hydro? Hydrogen. Does that make sense? What if you see oxide? What element do you think of? Oxygen. So when I give you hydroxide, what 2 elements does that sound like I'm bringing together? Hydrogen and oxygen. And if you look, it's an OH, the formula for that, right? So that's when you have to get memorized. You have to pull it together. And if you read that formula carefully, you should bring it together. Cyanide, you're on your own. I don't know any tricks for that one. Okay, so with that, moving on. Chemical formula for aluminum sulfate. Did you guys figure out where we find things that end in 8? It really speeds things up once you make this connection. At the bottom. Anything that ends in 8 is a polyatomic ion. So what's the formula for sulfate? SO4. So automatically I'm looking for something with SO4. I don't have SO4. No SO4. I have an SO4 and I have an SO4. But I've got to figure out which one it actually is. So now I've got to look at charges. What's the charge of ammonium? +1. What's the charge of sulfate? -2. Well, if I just had one ammonium and one sulfate, does that add up to 0? No. So could this be it? Nope. And that's why in this one it works, because we have 2 of the ammoniums and then 1 of the sulfates. So is this helping to go through like this? See how we're tying in a bunch of different things? That's kind of one reason I wanted to be able to do this. Okay, what is the name of CuO? Well, what's Cu? Copper. How many people knew that? You just don't want to say anything. You can raise your hand. No one else can see it. Okay, one of you. Okay. Okay. O is oxygen. Okay. Well, we got one person who memorized that. So we've got copper. We've got oxygen. There's only 2 capitals, so it has to end in what ending? Ide. Yes. You in the third row, you got it wrong. Okay, remember it's IDE. Okay, so it's copper oxide. So with that, well, we can probably rule out this because, well, we're not doing that. Okay. And rule out that. So we need to go copper oxide. Hey, copper 2 oxide, copper monoxide, copper oxide, lithium chloride. Well, I think we can pull that piece out. So copper 2 oxide, copper monoxide, copper oxide. They all have the required elements. One of those I can immediately rule out. Which one can I immediately rule out? And this is where, if you guys were actually really clicking in when we were talking about some stuff, your periodic table definitely helps, especially if you've been writing stuff down on it like I've been asking. What?
Is it the copper 3 oxide?
Copper 3?
Sorry, ruling out.
You're saying rule out this one?
Yeah.
Okay. Unfortunately, no, that's not it. Okay. Now, and here's the thing. Prefixes are never used with metals. Prefixes are when we don't have charges. And that's always when we're bonding covalently. And remember, metals are always going to take charges because they're always going to share, right? So that's where we can rule that one out. Does that kind of make sense?
Yeah.
Good. So yeah, prefixes will never happen with a metal, so we can rule that piece out. So now we've got this and this. They both say copper oxide. The difference is whether there's a Roman numeral 2 or not. That's going to determine whether we go left or we go down. Which one is it? Why the one with the Roman numeral?
Because copper is a metal and it's in the space of the Roman numeral.
Remember I had you guys mark this on your periodic table? And what did I say these always needed? Roman numerals. All of these guys need Roman numerals. As a result, we do need to have this. Okay, calcium nitrate 8. Ooh, we got another 8. So where should we be looking? Jordan, point. Don't point up. We already rolled those out.
What?
Am I going left, right, or down?
Left.
Left. Okay, so you're saying nitrate, so you're saying this one or this one. Why did I rule that one out? Yeah, it's aluminum. It's not even calcium. Okay. But now we've got this one. How can you rule this one out?
Because parentheses.
Okay, well, this one has parentheses too. You were right to rule this one out. I just wanted to see if you knew why you ruled it out.
Because it has two charges.
Not that it has two charges. Notice that one says NO2. That's an NO3. Now, if you look carefully on that chart, you're going to see that you have nitrate, which is NO3, but you also have nitrite, which is NO2. So you really got to read those carefully, just like you have sulfate and you have sulfite. So you really have to read these things carefully. So yeah, you were right and you ruled that one out. That was good. So the question is it going to be top or bottom? We know we're going to the left. That's great. Now we got to look at charges, right? What's the charge of calcium? Always.
2 plus 2.
Plus 2. Okay. What's the charge of nitrate?
Negative 1.
-1. So can I have just one calcium and one nitrate? Does that add up to 0? Nope. That means I can rule this out. Okay, iron 2 chloride. So once again, what does this tell me? What does that Roman numeral tell me? The charge of the iron. Give me the charge of the iron. That means that iron is going to be a +2. And the charge of the chlorine is? Yeah, same as it was up here, -1. Is that stable? What do we do? Cross down. So we want to find FeCl2. And hey, I've only got 2 choices there. And it looks like we can rule out the K. Could have done that to begin with, I guess. KOH, potassium hydroxide, KOH, KOH. Oh, keep in mind, hydroxide. Hydro, oxide, so there's my OH, right? And that's why you see OHs in both of these, so they're both polyatomics. Question is, do I have 2 OHs or 1 OH? Which should it be? 1, because the charge of potassium is +1, hydroxide is a -1, right? Aluminum sulfide. Well, it's either a 2-to-3 ratio or a 1-to-2 or 1-to-1. What's it going to be? Check your charge. What's your charge of aluminum? Reading your periodic table. What do we got?
+3.
+3. What's the charge of sulfur? What? -2. Yeah, because we have that at the very top of that column, right? Oops. So if we look at this one, ALS +3 -2, does that add up to 0? So it can't be that one. AL2 +3, 2 times 3 is 6, 3 times 2 is 6. We have a winner. LiCl, well, could have went that way, but that would have been us a loop. So lithium, there's only 2 elements, so it has to end in what automatically? Well, I found the button that lowers the chair. So that was interesting. Okay, 2 elements has to end in what? Ide. Okay, well, they both end in ide. So lithium chloride, lithium 1 chloride. Which one would be correct?
Lithium chloride.
The lithium chloride. Can lithium have any other charge? No. So the Roman numeral doesn't do anything. It has no other choice. So if we're going through and do that, that would have been our sequence for that. Sorry, my pencil apparently gave up. See how we reviewed a whole bunch of concepts with that? And that's kind of what I was looking for with that. Okay, so with that, I'm going to stop this video and prep for the next one. That way you're not watching a huge thing for those people at home. And I'll start another one in a minute.